Okay, for lab number 1, you need the following components. First one, 2 banana leads, banana to banana, and then 2 banana tube grabbers, and then 2 skull probes. And then to make the inductor, you're gonna need like a plastic tube, like this one right here. That's a plastic tube. And then the fancy name for this is reluctance reducer, but it's actually just a pallet. It's like a magnetic material that we're gonna place inside, inside the tube later on. Okay, so those are the 2 components for the inductor, as well as when you make the inductor, you need to wind a wire, and this wire has it's enamel type of wire. Okay, and it's number 26, as you can see. Right, so we're gonna make the winding using this wire, and then these are called Kapton tape, right? Kapton tapes, and we're gonna use these as well to make the insulation between wires. And then we're gonna need measuring tape, a scale, and sandpaper, because we know this is again enamel, so you have to get rid of the enamel later on once to make the electrical contact with the test module, which is right here. So here's the test module, right? And so we're gonna connect our inductor later on to this test module. Okay. Okay, so I'm gonna make the inductor using this plastic tube and this wire, gauge number 26. All right, and then from my calculation, looks like I'm gonna need 120 turns. You can verify with your own calculation, see if you need the same number of turns. It doesn't have to be 120 turns, but based on mine, it is 120 turns. So I'm gonna make that 120 turns around this plastic tube, and the way I'm gonna do this is I'm gonna divide the number of turns by 3. So there's gonna be 3 layers, right? Each layer is going to be 40 turns, right? 40 times 3 is 120 turns. So 40 turns for the first layer, and then on top of it, it's going to be the second layer, another 40 turns, and then the last layer, the top layer, is going to be another 40 turns. And between those, between 2 layers, I'm going to put Kapton tape, right, to separate the 2 layers. Okay, so don't just wrap it and then without any insulation. Okay, and then even though this is already enameled, but I think it's a good idea to make it a more stable windings, to use Kapton tape. Another thing is that when you make the turn, make sure that you make it into a one direction only, right? If you wrap it around this way, right, clockwise, from your point of view is clockwise, then make sure that you make the coil, right, make the turns clockwise. And then once you hit that 40, because I need 40 times 3, right? Let's say I'm doing the I'm winding number 40. Once I'm done, then I don't go back this way, right? Instead, after I've done number 40, then I'm going to cross over, right, or what do you call it, extend the wire, right, to the beginning of the first layer, right? So back from the beginning, don't wind it back to the front that way, right? So extend the wire back to the beginning and then do the 40 that way. Okay, all the way to the end again, extend the wire a little bit, and then you start from the beginning again for number 3. And remember, in between the layers you need, or I will put Kapton layers just to make the windings or the connection or the coils more stable. Okay. Okay, I just finished winding the first layer. As you can see, I started from your right hand side, right, of the plastic tube, and I put an extra length of wire because we're gonna need this to make the connection to the module here, the test module later on. Okay, so we'll do that later. But notice that took me some time to make this layer, because you have to do it carefully, and you can see the windings kind of tight, right? Leaving hopefully no space between each turn or each winding. Okay, so that's what you need to do. And next I'm going to make the second layer. Okay, I'm gonna put this wire across to the beginning of the winding, so not like continue winding to the front, but I'm gonna extend the wire that way, and I'm gonna start the winding for the second layer. Okay, so that's what I'm gonna do next. Okay, as you can see, I just move this or extend the wire a little bit, right? That's the end of turn number 40. I extend the wire a little bit so that I can start from the beginning of the winding, just like the first layer, just like that. I'm going to start winding the same way, clockwise. All right. Okay, so here's the inductor that I just made with 3 layers. And the third layer doesn't look as pretty as the first one, and it gets more difficult to make the winding as you are adding more layers. But yeah, that's basically what it is. I'm putting more wire on the other end, just in case I need more turns. Okay, if it's not giving me the right inductance or less inductance, then what it's supposed to be, then I can add more winding to increase the inductance later. Okay, so that's why I'm putting more wire at the other end. Okay, I'm going to measure this with impedance meter. I'll show you later on what that looks like. But before I do that, I want to make sure that I could have a good electrical contact on this wire, because this is still enameled. So I need to scrape it off using sandpaper. That's what I'm going to do. I'm going to scrape it off, okay, until the enamel is off, until the enamel of this one end is gone, and then I'll do the same thing for the other end right here. Okay, I'll do the same thing, and once I've done that, then I can start measuring the inductance of this pretty looking inductor. Okay. All right, now I'm going to show you impedance meter or LCR meter right here. We have a couple in the lab. This is one of them, and I'm going to turn this on. This will be able to measure inductance, capacitance, as well as resistance. Okay, so right now it's already turned on, and it's already set up for 10 kilohertz, which is what we want on the hardware portion of the experiment. And then I'm going to choose L right there. I can change the function to different values, different measurement, I should say. That's for capacitance. Here's for the inductance. You can see the unit changes as I move these around, right? As you can see, now I'm gonna choose L. That's what we want. And then let's see, in order to change the frequency for this particular meter, I can just use arrow to do that. See, if I do that, I can change the frequency of measurement that I want for this inductor, right? But this is already 10 kilohertz. I'm gonna do I'm gonna do escape. Is it here? No, I'm gonna do escape, which is right there, and then that's it. Now I'm ready to measure the inductance. Looks like it'll give us the inductance as well as the resistance of the inductor. Okay, so we'll do that. So right here, if you look at what I have right now, this is the inductor that I just built. I'm gonna, oh, by the way, I already scraped off the enamel from the wire. You can see now that there's no more red part on the tip of that wire. Same thing here, right? There's no red portion on the end of that wire. So I'm going to now measure the inductance without our magnetic material. Okay, so there's nothing inside, just air, right? Air core, and you can see the inductance, if you have an air core, is 26 microhenries, right? I don't know about this resist. I don't think that's correct, right? Maybe I can do DCR. Oh, that's even worse. Oh, but that's actually milliohms, so that's more like it, right? So that's the DC resistance of this inductor. Okay. Yeah, this one is 464 milli actually, so that's not bad. Okay, but that's what you get with without the magnetic material inside. Okay, which I'm gonna call this pellet. Now I'm gonna I'm going to now let me reconnect this, right? So okay, 26, around 26 micro, right? So now watch, I'm going to put this inside. So now it's no longer an air core. Now I'm gonna have a better magnetic flux inside this inductor, right there. So now it's inside. Hopefully you can see that. So I'm gonna take it out again. Let's see that. So right there, I'm gonna push it in. So now it's inside the inductor. Maybe make it a little bit to the center of it, right there. And then take a look at what happens with the inductor now. Is about 40.84, which I believe is close to what I want. Okay, so I'm gonna leave this, right, and it looks like my inductor very close to the inductance that I'm getting from this inductor is very close to what I'm wanting, right? So I'm gonna leave it like that. I'm not gonna add any more winding or take away any more turns, right? I'm gonna leave it as is. I'm gonna cut this shorter because I don't need this extra wire anymore to make more windings, because it seems like I have enough inductance, okay? Right there. All right, and let's check to see the ESR or the DC resistance. Right now it's saying 0.9 ohms. Let's see if I do the DCR from here. Yes, it's different. I'm guessing this is the actual DC resistance, meaning it's being measured at DC, right? So that's why it's called DC resistance. This is what we want. The other one, it seems like it's being measured at, it's being measured at 10 kilohertz, right? So you see the difference in terms of the resistance of the inductor when you measure it at 10 kilohertz versus when you measure it at DC, right? But when we do ESR, typically we want the DC resistance of the inductor. Okay, I'm going to take this out, and it looks like it's the same thing, right? It's the same number without or with the there you go, without the magnetic material. That makes sense, right? Because it is DC, so it should not make any difference in terms of whether or not you have the magnetic material inside. It's just going to be a function of the length of the wire. All right. All right. I'm going to measure, the weight of this pellet. Turn this on using the scale. And I don't know if you can see the number right there, 0.768 grams. Okay, so we're going to record that as the the weight of this pellet. Okay, and turn it off. And that's it. Okay, now I'm going to test our inductor. As you can see, the inductor is being connected to the test module right there, and then it's connected to the power supply, as you can see, right? And then it should be giving us 48 volts. And then let's see the pellet is already inside. We'll do this trial. We'll do this test 3 times, and when the pellet lands, I'm going to mark so that we can see the distance. So we can measure the distance. All right. So here's the first one. Turn on, and then now it's charging the capacitor. And then once I turn the switch on, that means we're gonna transfer the energy to the inductor, and in the process we'll shoot the pellet out of the tube of the inductor. Okay, right there. Okay, second test. I'm going to charge the inductor again, the capacitor first. Right, I'm gonna reset this first. I'm going to charge the capacitor, okay, and then I'm going to discharge the cap through the inductor, pressing this button right there, and that one is not that far. Okay, next test. Okay, let's see, charge it, and then about 3 seconds, and I'm going to discharge to the inductor. Okay, that's that. Okay, it's about, I'm guessing about that much. Alright, this is just an approximation. Okay. Alright, another trial. Okay, again, turn on the power supply to charge the capacitor, about 3 seconds maybe, and then I'm going to discharge to the inductor. Okay, here's the last one, last trial. Charge the cap around 48 volts, about 3 seconds or so, and then I'm gonna unplug the power supply, discharge. Yeah, it's about this much again for number 5. Okay. Alright, so next I'm gonna measure the distance, okay, using the measuring tape, and I'm gonna write it down so you can see later. Okay. Okay, we just did some measurements on the distances, right, from trial number 1, which is so far 10 inches, and then 2, 3, 4, 5 is around the same distance, right, as you can see, especially 2, 4, and 5, pretty much the same, and then 3 is about 6.125. So please record this. Okay, write this down. 4.5 inch for number 4, 4.5 inch for number 5 is about the same, right, and then so on and so forth. So hopefully you can see the numbers. And then if you look at the height of the tube from the from the bench level right there. So that height right there, we measure that to be 1 inch. Okay, so that's the height right there is 1 inch, and that's the picture that that I tried to draw. Right, that the height to the center of the tube is about 1 inch. All right. Okay, this first one, I'm going to test this inductor, measuring voltage waveform across the inductor as well as current through the inductor, and I'm charging the inductor with 48 volts just like before. Channel A is voltage, channel B is current, and let's see if we can capture the waveform once I release the energy from capacitor to inductor. Right there. Okay, I'm going to change the level, the scale for the current. Okay. So I'm going to redo this. I'm going to reset the voltage, the charge first. Okay, and then let's do the experiment again. Okay, not yet. Okay, so now it's charging. I'm using different current scale. I mean channel B scaling, which is again measuring current through the inductor. Right? Okay, I'm going to discharge to the inductor now. 3, 2, 1, right there. Okay, also I forgot to mention that the probe is 10 times. Okay, the probe setting. Okay. Okay, the next measurement is the same thing, voltage and current waveforms through the inductor, except that this time I'm gonna put the pellet inside. Okay, and then same thing as before, I'm going to charge the caps and then wait for a few seconds, and then hopefully we can capture the waveform. Okay, 3, 2, 1, right there.